All right, so here's a recap of all of the tests we know. Remember, we use tests on series. Test for divergence. Test for divergence, we find out if it diverges or if we have to do another test. And that's by taking the limit of the nth term. Integral test. The integral test is we make a function out of the nth term and we change it to x's, and as long as that function is positive, continuous, and decreasing, then if that integral of the function converges, the sum converges. If the integral of that function diverges, then the sum diverges. So when is this test useful? Remember when e and ln are in there, and we don't know if the sum adds up to what the function converges to. So when is it useful to do tests for divergence? Well, I don't do tests for divergence unless nothing else seems to be working. Geometric sum. Geometric sum, I'm looking for a number to the nth power. A number to the nth power. And only if I'm asked to find the sum do I find the a over 1 minus r. Otherwise, I'm just looking to find out if r, the absolute value of r rather, is greater than or less than 1. If I'm asked to find the sum and it looks like a fraction that I can do partial fractions on, that's when I would do the partial fraction decomposition, find the s sub n and take the limit. P-test, best test ever because it's so easy to use and just have to get it memorized, correct? Basic comparison test, really useful when it works. Bigger converging is good, smaller diverging is good. Remember, both of these have to be positive term series. Remember, there's no squeeze theorem. There's only one inequality when we're doing basic comparison test. And these are some useful facts that we went over. Limit comparison test has to be done on two terms, two series that have positive terms. We take the ratio of them, and if it's a number, and that number c is bigger than 0 and finite, meaning not infinity, then they both do the same thing. This is useful when the basic comparison test fails or when there's too much going on to even try BCT. And when that's happening, you make a new sum from the highest powers. So let's go back to sequences. This was the one section way at the beginning that we had on sequences. So in general, we're taking the limit of a sequence. I guess I didn't write it down. So it's given by its nth term, and we usually seen it given like this. So we take the limit as n goes to infinity to find out if a sequence converges or diverges. These are facts, this limit fact. We've used in sums as well, but these are limit facts. If the absolute value is k is less than 1 or bigger than 1, we're taking a number to the nth power, a limit of a number to the nth power. So this one here, the limit as n goes to infinity, if I simplified this, this would be 8/3 to the nth power, right? So this would equal infinity. So that means that this sequence would diverge. Remember, if I'm going to do a limit and I see I can't do highest powers and I'm going to need to use L'Hopital's, then changing it to x's. And as I'm changing it to x's, I'm going to use the fact that I know from limits properties that 3 comes down. Now I'm ready to take and do L'Hopital's. So simplifying, I get 3 over 2x squared. That gives me 0. Since it goes to a number, it converges. So if I start to take a limit, because that's what you do in general for sequences, and I get dne over infinity, that's bad. That means absolutely nothing. So I need to do a squeeze theorem. So squeeze theorem is when I have the two inequalities, and I build the function in the center, and then I take the limit as n goes to infinity of the two outside functions. So this one, which gives me 0, and this one, which gives me 0. So therefore, I know that the one in the middle converges to 0 also by squeeze theorem. Cosine squared It's just squeezed between 0 and 1 because it's being squared. So I divide everywhere by n cubed. Not going to do that one. It's still going to be 0. So limit as n goes to infinity of 0 is 0. Limit as n goes to infinity of 1 over n cubed is 0. Therefore, I know this converges to 0 also by squeeze theorem. Then I had this alternating sequence rule, right? The sequence rule, when it was changing sign, it could be any one of those. Doesn't matter what the power of the -1 is. We took the limit of the positive part only. If it equaled 0, then the whole thing converged to 0. If it didn't equal 0, if it went to any other number, the whole thing diverged. So here we go. This would be my a sub n. Take the limit of that, taking highest powers, so n over n squared, canceling, I get 1 over n, 1 over infinity gives me 0. So that means the whole thing converges to 0. If I go to take the limit of the nth term on this problem, take highest powers, I get e to the n over e to the n, that's 1. Since it doesn't equal 0, this one diverges, right? Because of the alternating sign. So that was a little bit of review, things we've done so far.